This particular video, we're going to go through and start solving some exponential functions. So let's get started. Our first example, solve the exponential equation using common bases. So that just means that we've got to go through and get common bases for these. So in order to do that, I already have a 5 here. I can't change that base any. That's the smallest base I can go to, but I've got 25 here. 25 can be re-expressed as 5 squared. So let's go ahead and rewrite this. So I have 5 to the x is equal to 5 squared, which is then raised to the 3x plus 2. Remember, when I have a power raised to a power, I multiply my exponent, so I get 5 to the x is equal to 5 raised to the 2 times the other exponent, so that's 6x plus 4. The rule states that if we have the same bases, then the only way at which for these two things to be equal would be if our exponents are equal. So we can kind of just get rid of the 5s because the exponents would have to equal each other. So x is equal to 6x plus 4. I'm going to subtract 6x from both sides because I like to have the x on this side. So if I subtract 6x, I get negative 5x is equal to 4, which then means x is equal to negative 4/5. And then we can go ahead and substitute that back in, check it out, and you'll see that it works. All right, next example. Solve the exponential equation using logs and the rules of logs. So then what I'm going to need to do is recall that from the definition of logarithms, that if I have y equals some base to the exponent, then that is the same thing as taking log base b of y, and that equals the x. Okay, so then this is the definition. Now I can rewrite that if I had an e, which is what we have in this case. Remember that using log base e just means I have a natural log. So this would be natural log of y is equal to x. So these are two of those things that we need to remember from all of our work before. So let's look over here then. What I need to do is I need to isolate this equation so it looks like this equation. So I've got to isolate the variable that is the exponent. So the first thing I need to do is I'm going to need to go ahead and subtract 5 from both sides. So now I get 4 e to the x is equal to 7. Divide both sides by 4, because again I need to get this base and the exponent by itself. So I now get e to the x is equal to 7/4. And then I need to go through and excuse me, and rewrite this based on the definition that I have here. So, okay, x is the exponent, and that's what the whole job of the log is to do, is to find the exponent. So that means the exponent is equal to natural log of 7/4. Then we just grab our calculator, and we'll go through. So I need to find the ln button. The ln is right near the log button. So I need the natural log of 7 divided by 4. And that gives me, the calculator goes through and says, all right, well, x is equal to 0.5596. Depending upon what the question asks, it might ask you to write this to the nearest hundredth, nearest thousandth. In this case, why don't we say to the nearest hundredth? So then we're going to round this to then, I'll even write here just so that you can remember. So nearest hundredth. In that case, then it means x is equal to, so here's the tens, here's the hundredths. All right, so now I get 0.56. Next question. This one looks a little different than the other one that we just did, but I should hopefully recognize that this is a quadratic type equation. Now, it looks a lot different than we're used to, but remember, the highest one has to be twice the next lowest exponent. So let's rewrite this as a quadratic. So to rewrite this as quadratic, e to the 2x, move all of this stuff to the other side, minus e to the x minus 2 is equal to 0. So like I was saying, in order to have a quadratic type equation, this exponent has to be twice this exponent. It just has to be doubled. So now I'm going to set this up in factor. The first terms in each, well, remember the first terms are going to come from this, so it's just going to be an e to the x in each. This sign here tells me they're opposites, so plus and minus, that's what the signs are going to be. I need factors of 2 that differ by 1, and the largest one is going to be negative. So that makes this 2 here, and that makes this 1. So now that means e to the x is going to equal negative 1, or e to the x is going to equal 2. Now, based on the definitions and what we already know about exponentials, I can't, based on the way that this is set up, no value of x will give me a negative number. So that means this right here is not possible. The only way that I could have this become negative is if there was a negative in front. So this is an extraneous solution. So now what we need to do is we need to use our definitions like we did before of the log. All right, remember the job of the log is to get the exponent. So then that means x is equal to, then we switch it to the natural log of 2. So in this case, then, the only value that will work, again, using my handy-dandy calculator here, natural log of 2x is going to be approximately, we'll go to the nearest hundredth again, 0.69. All right, so I hope that this was relatively helpful for just going through and solving exponential type equations. Thank you. And again, this is Robert Main from Charahoe High School. Have a great rest of your afternoon.